I'm sure you came to this talk because you care a lot about optimizing your downloads, and you care about that because you care about your users and keeping them, but also keeping them happy, making sure they're not spending a lot of time downloading your app, or your app is not taking a bunch of storage and disk space. So I'm going to start this talk actually with a pretty bold statement. If you're here, you absolutely 100% should be publishing your app with app bundles. And at the end of this talk, if you disagree with me, come talk to me. Either I have to change my presentation or bring feedback back to the product team. So with that, let's begin. So to kind of appreciate why app bundles is so important, we kind of have to add some context by going through a little history of Android. So in the beginning, there were just a few Android devices. Oh, just a few devices. So all the apps are pretty lightweight. Very few screen densities, CPU architectures, and so on. So the APK framework kind of helped, worked very well, right? So you built the binary that you're actually going to deploy to an app, and it had the minimal amount of things you needed to run on an Android device, your code and resources. So for 10 years, we've kind of used APKs as the way of publishing and deploying apps. And let's see how that's kind of worked out. So after a few years, we started having more devices, different form factors, tablets, different screen densities, different CPUs, CPU architectures, and obviously locales. And then app sizes started growing. And one thing that we noticed very clearly is that as APK size grew, the conversion rate from people downloading to actually installing your app and using it started to drop quite clearly. And it's not just conversion rates, right? So you have slower downloads. People are generally impatient, and I'm sure you know this. You have higher uninstalls and lower update rates. And as my girlfriend can attest to, she actually deletes apps in order to just take pictures. So, the bigger the app, the more likely it is that it's going to be uninstalled. And that trend has just kept on growing. And today, apps are about 5 times larger than they were back in 2012. So we started to address this with multi-APKs, so creating optimized APKs that each target a specific device configuration, right? So here we have 4 APKs, one that each that target a different screen density. But then when you add ABIs, you have that many more APKs that you have to build. And then if you're targeting min-SDK version, that many more. And it just keeps growing. And you have to not only build them, you have to sign them and manage them. So, I mean, it's pretty easy to kind of, in Android Studio, to kind of set up the different kinds of configurations you want to support. But then you have to, by hand, you have to kind of figure out how you're going to assign version codes such that you can update them all without them stepping on each other's version code. It's kind of a pain in the butt, right? And today, the amount of devices has just skyrocketed. And this is actually someone else's slides that I stole. So I don't even know the robot that uses Android, but I'm curious about that. So with that, and you upload all those APKs, it's a lot to manage. And there's a better way to do this. So Google introduced the Android App Bundle. So we'll talk more about why this is so important. But right now, what you need to understand is, so App Bundle is an officially supported publishing format. It's one artifact that Google Play uses to generate all the different APKs that support all the device configurations you want to. And it enables dynamic delivery. So what is dynamic delivery? So if we're looking at the legacy APK scenario where you're just kind of creating one APK that fits all devices, you have to cram all your code and resources into that one APK. But with dynamic delivery, what Google Play is able to do is just pick and choose just the code and resources that each device needs to run your app, and only pushes that code and resources to the device. So you immediately start seeing a lot of size savings by just building an Android app bundle. So after you upload the app bundle, Google Play processes it, infers the different kind of configurations you're supporting and your general project app structure from that app bundle, and generates, signs, and deploys those APKs to devices. So when I say sign, a lot of developers immediately say, so do I have to give up my signing key? You do have to subscribe to app signing with Google Play, but I assure you, your key is safe. The keys are stored in the same infrastructure Google uses to store their own keys. There's engineers working around the clock to make sure that all of that is super safe. So let's take a deeper look into dynamic delivery and what app bundles and how they kind of work together. So basically, dynamic delivery is deferring APK generation to Google Play. So you compile your app in code and resources up to the point you would package them and sign them as an APK, but you put them into a zip and send it to Google Play, and then Google Play kind of does that final step where most of the pain is. So for pre-Lollipop devices, Google Play will generate essentially multi-APKs, so single APKs that each target that specific device configuration. But you don't have to build them all yourself. You don't have to sign or manage version codes. For Lollipop and above, it uses a platform, a mechanism called split APKs, and that's basically where you take multiple APKs and the device is able to treat them as a single installed app. So you can actually break out the app into separate components, and then Google Play just sends the bits that are required as they need it, as the device needs it. So let's kind of take a look at how that kind of looks in a dependency graph. So you have your base APK. So these are all split APKs that we're going to talk about. So this is your base APK, and that's basically built from your typical application module. So it's the module that applies the application Gradle plugin. And then automatically, based on how you structure your code and resources and your locale-specific resources and your screen density-specific resources, Google Play automatically creates what are called configuration APKs, where each configuration APK includes maybe like the English resources or the French resources or high-density images. So you no longer need the splits block. In fact, when you're building Android app bundles, the Gradle plugin completely ignores this. So then what you're also able to do is modularize your app such that you can have what's called dynamic feature APKs. And that's created from a brand new module or a plugin, which is the dynamic feature plugin. And that allows you for devices to download specific features after install time. So using that split APK mechanism, you can say that here are the core code and resources that I want to have at install time, and here's some stuff that maybe 10% of users will need. So I'm going to save that for later, and if a user needs that, then we can download it later. A good example is like an e-commerce app. So an app where you can browse and buy or sell stuff online. And let's say 90% of your users only care about browsing items that are already available. So that might be in your base APK. But for the 10% of people that actually want to sell things, all that kind of stuff, those activities and everything can be put into a separate dynamic feature. And dynamic features will have their own set of configuration APKs, where they'll have density configuration APKs, APKs, and then your language resources in separate APKs. So they're still only getting exactly what they need. So how is this represented in an app bundle? So an app bundle, for the most part, really resembles your local project structure. So as you can see, the base module is in a directory, and it has its compiled dex files, its resources that are already kind of grouped by ABI and locales, and then directories for each dynamic feature module. And it also includes metadata for whether you want certain modules to be on demand or included automatically, and we'll talk about that in a bit. So if there's anything you can take away from today, it's that with the latest Android Studio version, you can, I'd say 99.9% of projects today can just do this, go to build bundle, and just select bundle, and you can build an app bundle without doing anything. So just, if you do anything, try that. Build a bundle and upload to Play Store and see what happens. I mean, it really is that easy. So, but we'll talk about some more interesting stuff, but that is the biggest takeaway. And you can also build from the command line. So when you build APKs, you invoke the Gradle task, assemble debug. It's as easy as bundle release. So even if you're a command line user, you can build bundles. And then when you upload to the Play Console does a lot to kind of help you understand how impactful that app bundle is by quickly breaking down the size savings for most of your devices just from using app bundles. And you can, when you're on Play Console, you can actually see all the different devices that your app bundle supports and download APKs for each device from Play Console if you wanted to test it out. Okay, so let's talk about actually configuring your project for dynamic features. So just kind of high level, there's kind of two scenarios, right? So when someone installs your app, you're going to get the base APK and its configuration APKs first. That's what's installed first. And afterwards, you can download dynamic features and their configuration APKs on demand. So because everything kind of depends on the base APK, we have to kind of make sure that the base module is set up for dynamic features. So just a couple of takeaways. Your main entry point for your app still has to be in your base APK, so you still need to set that up. Your manifest, your base module manifest should include all the permissions that you're going to need, even for your dynamic features, and I'll tell you why. We'll soon kind of explore how you can immediately access code and resources from a downloaded module, but otherwise, you still need to restart the app before manifest entries are applied from those downloaded modules. So let's say you install a module that allows you to send SMS texts. Well, you'd need to restart your app before your app is able to ask that permission. But if you ask for it up front by including in your base APK, someone downloads that module, they can immediately start using that feature without having to restart the app. Base module still determines the version code for your entire app, so that's the only place that you'll need to include the version code. So when you update your app, you're actually going to increment the version code in the base module, and you'll rebuild your entire app bundle and upload it. And then Google Play uses that version code for all its APKs. So if you have a combination of split APKs on an app, all of them will be updated to the new version code. So the splits block is ignored, like we talked about earlier, but you are still able to control which configuration APKs you want Google Play to build. So for some apps, if you expect the user, for some reason, to change their system language frequently, you can actually disable just the language split such that all the language resources are packaged in either the base APK or the dynamic feature APK. So you can still do that, and you do that from the base module. So actually, like adding a dynamic feature. So we have our base module set up. Adding a dynamic feature is pretty easy, just like adding any other module, except you're going to use the dynamic feature module. You'll select the base application that you want it to depend on, and then you'll choose the module name, and that part is important. That's the name that you're going to use when requesting the download if you want it to be on demand. Other than that, it's pretty straightforward. So once you choose the base module, Android Studio automatically injects these dependencies. So in the base module, it says, okay, I have a dynamic feature that depends on this base module, and on the dynamic feature module, it says, okay, I depend on the app module, just like any other local library project. You'll also have some options for configuration on configure on-demand options. So you can choose to disable on-demand. So the useful part of that is, as you're modularizing your apps, right now, let's say it's monolithic, and you want to start breaking out features, but you haven't yet figured out how to gracefully handle error states and that whole flow. You can disable on-demand as you're still modularizing that feature, and then when you're ready, you can just enable on-demand. So that's why we include that as an option. And then fusing is important for pre-L devices. So if you remember, pre-L doesn't have support for split APKs. So they only have the monolithic but optimized multi-APKs. So by checking off fusing, you're saying, for the pre-L devices, I want you to include this otherwise on-demand module by default. So it'll just be included in that multi-APK. And you can turn that off if you don't want that feature to be supported on pre-L devices. So yeah, so this is just a little bit more about fusing. So once you do add fusing for a certain module, that automatically is included at install time. Okay, so when you do configure on-demand options, Android Studio automatically injects these manifest entries for you. So it gives you the distribution namespace, turns on demand, and sets the module title. I'll actually go back just a couple of slides here. So module title is right there. And it's important to, one of the places that it'll surface is that if your download is above 10 megabytes, you will, the device will request user confirmation, and it'll ask, do you want to download module title? So that's where that'll show up. And what happens is, what a best practice that Android Studio will do automatically for you is include that as a string resource in your base APK, in your base module, so that your base module has access to that string resource when requesting that module. So, and then fusing. So, okay, so let's talk about actually how we're going to request, monitor, and manage dynamic features. You've added them. You've done. You've modularized your app, and now you want to actually manage requesting them at runtime. So first thing you're going to do in your base module is you're going to add the PlayCore library. That's the API that you use to request on-demand features. It's available from Google Maven repo. So I mean, if you're using anything above Android Studio 3.0, you're already going to have that. And then you just add it to your base module like any other dependency. We're going to come back to this in a bit, but what you want to do as well is enable something called split compat, and that allows you to have immediate access to download APKs before they're installed. And the reason that's important is you actually require an app restart for an APK to be installed. So to kind of take away from the UX pain of that, you can enable this to just have access to the code and resources so you can still start an activity and such. There are some caveats, like we talked about before. It doesn't allow you to apply new manifest entries from that downloaded module right away. And UI, system UI components doesn't have access to any resources in that APK until you do a restart. So you can use the base module for those resources instead. Just have them in your base and then enable them or access them after you've downloaded that module or on-demand module. Okay, so the easiest way to enable split compat is to just declare it in your base manifest. Okay, so let's start talking about actually requesting the feature module. So use the split install manager to request immediate installs. So that's when your app is in the foreground. So immediately requests and starts downloading and installing your module. You can also request deferred installs for when your app is in the background. For example, you have a game and you want to start preloading some additional levels before the user gets to them. You can request that as a deferred. And then let's say the player is playing way too much and already reaches a level that hasn't been downloaded yet. You can change that to an immediate download in case like that. And you can include multiple modules per each request. So first thing we do is we instantiate the split install manager. And then, so we have a function to install a feature for picture messages. So we're using this exact same module name that we specified when creating the dynamic feature module. We create a request with that module name. And here's an example of where you can request more than one module per request. It's pretty straightforward. And then here's actually submitting the request to the manager. So you start install, and your app has to be in the foreground. Otherwise, you get an error state, access denied. And the PlayCore library uses a fire and forget strategy. So after it makes a request, that's all it really does. It's not going to retry the request if it fails, or it's not going to try to handle that gracefully. All it can really do is tell you, has a request gone through or not, and then you'll have to monitor what if the download has actually started happening. So register listeners to kind of keep track of that. Request for deferred installs is pretty easy. You just use a deferred install function. And again, this is great for when you're requesting in the background. This one, you can't actually monitor like you can the immediate installs. You can't actually monitor the progress. So all you can really do is kick off the install in the background, and then when your app is in the foreground again, just check whether the module is actually installed before firing an intent into it. So let's talk about monitoring the state. So you can use the state updated listener to monitor progress and update UI, like progress bars, handle requests for user confirmation, like we talked about. If a module is a certain size, you'll have to actually handle user confirmation appropriately. And then launch activity load resources immediately. So first, we register a listener to get a callback with the updated state for whenever it updates. So you can also register on resume. So let's say you started an immediate install. The user puts your app into the background, and then you come back. You want to pick up where you left off and keep getting updates to the listener, and then just unregister on pause. So one of the first states that's kind of important is obviously downloading. You want to make sure that the request has gone through and it's actually actively downloading. So one thing you can do is create the progress bar to kind of show the user that the download is active. So you can pass the state object and actually find how many the total size of the download and how much the download has progressed, and kind of use that for your UI. And then afterwards, after it's downloaded, you'll go into installing state. That is pretty quick, so you're not going to really spend too much time there. And then you're going to go into install. So this is when things kind of get interesting. So you can start accessing your code and resource immediately if you've enabled split compat. And you do that by refreshing the app's context. So you can see, just create a new package context, and then now treat it like any other asset file and just start accessing any resources in that module. And for native libraries, just there's a separate load library in the split install helper. Don't use the system load. Use that one instead. So this is the case where if you have a download module which is of a significant size, you're going to have to get user confirmation first. So we have a pretty boilerplate function for that. What's going to happen is you're going to get the user will get a dialog box, and it'll ask them whether they want to download or cancel. If they hit download, the state will go from pending to downloading to installed. If they hit go cancel, they'll get the cancel state, and you can either try again or handle it however. If they destroy your app and load your app again, that state will stay in requires user confirmation, which is why it's important to reattach the listener on resume and kind of handle that again and fire off this dialog. Some other states not slide worthy are pending. Just means that it's your opportunity to start creating initialized UI components for your progress bar. Downloaded, you won't see if you enable split compat. You'll immediately go to downloaded or installing state. And then failed is basically like, for whatever reason, we actually don't look into too much. We don't provide too much information why something's failed. So it could be lack of storage space or what have you. It's kind of your job to ask the user if they want to try installing again. And then canceling, we'll talk about just really quickly. It's super easy to cancel and install. Just provide that session ID that you get from the success listener. So failure states for the actual request. So when you start a request, you can add the add-on failure listener to kind of get an error state, if there is any. One of the common ones you might see is network error, because you might be downloading a large file you want to be on Wi-Fi. So you will get a network error, and then you can just provide UI dialog to the user to first connect to Wi-Fi or whatever. Another one is, so currently we only support having one download at a time for one active request at a time. So one thing you'll need to check for is active session limit, whether it's been exceeded. So if it has, just check for active downloads. So we can see that here. so you get the state and then check out of all the session IDs which ones are actually downloading. If you find one that is currently downloading, you can either cancel that current request or turn it into a deferred install so that it just installs later in the background. So other errors are if a module is unavailable, it's just an error. Maybe you haven't set up the request appropriately. API not available is what you get when you're making the request on a pre-L device, which can't handle, doesn't support on-demand downloads. Access denied is when, we talked about this briefly, it's like when you try to make a request in the background for an immediate install that's not supported. And then, yeah, just service has died. That's basically kind of like a catch-all. You just have to try again. So uninstalling modules is, they don't occur immediately. So you're basically tagging certain modules as you don't need them anymore, and you let the system kind of determine when to delete that from the disk to free up storage space or what have you. So let's talk about local testing. One of the big kind of concerns for developers is integrating app bundles into their CI builds. So we're going to talk about a tool that's central to Android Studio, the Gradle plugin, and Google Play Console. It's actually the tool that runs in the background for all those things to generate bundles from your project, to unpackage them into APKs, and then sign them and all that. So you can actually integrate that into your local builds and do that all locally as well. But I must say that the best way to test your app, especially if you have on-demand downloads, is through the internal testing track on the Play Console. So it's a brand new testing track that allows 100 internal users, and it's almost immediate. As soon as you upload your bundle, it'll be available to them within a few seconds. And that's the only way to really test the whole on-demand download workflow. But it does have publishing API support, so even from your CI builds, you can constantly push the latest app bundle to your internal testing track, so your internal users have the latest build. So just to recap, building app bundles from command line is pretty easy. You just kind of kick off the Gradle task to build your bundle. And then using Bundle Tool, you build what's called an APK set. So it takes your app bundle and builds every single APK, whether it's multi-APK, the split APKs for your base and your dynamic features, and puts it all into a zip. So you basically pass the app bundle that you want to build your APK set from and the target path for your output. But one thing you need to know is that unless you provide signing information, it's going to generate unsigned APKs, and that you can't really deploy to a device. So if you want it signed, you'll have to pass signing information for your key store password, and then the key and the key password. From there, once you have your APK set, you can deploy your app to a connected device simply by using the install APKs command. And if you have more than one device, you can actually specify the serial ID for that device. But building APKs for every single device is time consuming, and it'll probably eat up your hard disk very quickly. So there's different ways that you can actually build a set of APKs for a specific device for testing locally. So you can, if you have a connected device, you can just pass the connected device flags along with the serial ID, and then Bundle Tool builds an APK set of APKs just for that connected device. So if it's an L plus device, then it'll create split APKs. If it's a pre-L, it'll just build that multi-APK. You can also, if you don't have the device locally and it's not a connected device, so if, again, for CI builds, you can actually pass a device spec. So it's a JSON that actually describes the device you want to build for. You can generate a JSON for a connected device by using the get device spec command. And this is kind of what it looks like. So if you don't have that device, you can create something like this yourself. And then when you go build your APK set, you just pass the device spec. And again, it'll just build based on that device spec. OK, so moving on. So with the latest version of Android Studio, Android Studio 3.3, I think we're going to go to beta pretty soon. We're supporting app bundles that supports both the installed and instant app experiences. So how many people actually support instant apps right now? Just a show of hands, roughly. Okay, 1, 2. Half of those people are Googlers, I know. Okay. Okay. So I think a big part of why instant apps has been hard to kind of support as a developer is it really does require you to reinvent your app using different plugins, modularize it right from the get-go, and it doesn't kind of let you start from the state you're already in and work towards an instant app state, right? But now that's kind of changing with 3.3 tooling. You can support instant app experiences from your app bundle, and all it requires you to do is turn on some manifest flags and achieve some size restrictions. So if you get below a certain size restriction, we'll talk about that in a minute, you'll automatically get instant app benefits. So one of the immediate benefits is that you get a try now button. So if your base APK is instant enabled, so you enable that manifest flag, and it's under, I think, under 10 megabytes, you automatically get a try now button on your Play Store listing. So that allows users to try the base version of your app without installing it almost immediately. You don't need to specify URLs. You don't have to do anything. You just have to set the manifest flag and get down to below that size restriction. So configuring your project, like let's say you're starting a brand new project, you would just check this little box that says this project will support instant apps. So what does that do? Well, that really just, like I said, it adds the distribution namespace, and it just enables that instant flag to true. And that really is all it takes other than the size restriction. So speaking of which, so if you're, for regular apps, if you're larger than 10 megabytes, you need to kind of reduce the size of your base APK and its configuration splits. So that's a bit more complicated. So the combination of your base APK and configuration splits for any single device that your app supports needs to be below 10 megabytes. So if you achieve that, you automatically get the try now and web banners for free. If you get below 4 megabytes, then you open up a lot more discovery surfaces, such as search, ads, social, QR codes, and all that good stuff. And then you'll need to actually register URL to get those as well. For games, we kind of understand games are inherently larger, so we're kind of a little more relaxed on the requirements. So if you get under the 10 megabyte limit at all, you get all the discovery surfaces opened up to you. So how do we get to that lower size limit? How do we achieve that? Well, one way is like you can reduce the size of your image assets by adopting a WebP, or you can prune dependencies, especially the transient dependencies. As you can see here, the stuff that you don't need. But probably the best way is, again, to modularize your app. And there's some easy ways to kind of do that. So if you want to add an instant enable dynamic feature, it's really easy through the create new module wizard in Android Studio. You just select that. It's almost like creating a regular dynamic feature. You create, you select the basic application module that it depends on. You choose a module name, and then whether you want to include it in pre-L devices with fusing at the bottom there. So what does that do? It adds that instant flag to true. It disables on demand. I'm actually not too sure why you can't have both set to true, but you actually get a build error if both of them are set to true, so you got to pick one or the other. And then, yeah, fusing is disabled in this example. After that, each dynamic feature can specify its own entry point, so you can have a separate URL for each entry point. And let's say like people are on your web page and they just want to upload a picture to their profile, you can just have an entry point straight into that module. And that's about it. Thank you.